welcome to another episode of our Some Engineering podcast. And today we have Jason Reed. Jason is a co-founder and the head of product at Tabular. And Tabular commercializes Apache Iceberg. Jason, welcome.
Thank you, Lars. Very happy to be here. Appreciate it.
And so we're going to talk about both today. We're going to talk about Iceberg and Tabular, and maybe just tell me what does Tabular do and what does Iceberg do? And you guys come from Netflix. Like how did this thing come about? Let's go in.
Yeah. So I'll try and give the short version. We can dig into details, but ultimately, Tabular, the company, exists because we saw adoption of the open source Apache Iceberg project ticking up across a variety of really data forward companies. And we also saw that there were a bunch of duplicate patterns of infrastructure and systems that all those companies were having to build in order to help their Iceberg installations be successful. And we just felt like the biggest unlock for Iceberg, the open source project, was actually going to be making it much easier for companies that don't have super sophisticated data platform teams to get up and running. And so Tabular is just sort of the easy button when it comes to how do I plug the Apache Iceberg project into my infrastructure and be successful with it.
And so let's talk about Iceberg itself. Today, what does it do? And how did you come up with the project at Netflix? Like, what's sort of the evolution? And then how I know like your journey at Netflix started, if we go back 10, 15 years, like I think it started with Teradata back then. But how did you come up with the idea? How did you build it to what it does today?
Yeah, and obviously there was lots of people involved that can take very little credit, but I can tell the story.
Yeah.
Which, is a very evolutionary story, like most things in technology, and Iceberg was just sort of the next natural step once we got there. In hindsight, it seems obvious, but obviously in those moments, it never is. And so, it was probably, I think, 2018 when we first started using Iceberg internally at Netflix. And how we got there really was, like you mentioned, we started at Netflix with Teradata as sort of our data warehousing product to do analytics and all the data things we were doing. And it was about the time when Hadoop was gaining popularity and support. And we also felt like it made sense for both scale and cost reasons to explore, moving from Teradata into Hadoop. At the same time, Netflix was moving all of its infrastructure into AWS, into being, cloud-based. And so one of the novel things that we did, and this was mostly Dan Weeks, one of my co-founders, what he pioneered was using the Hadoop stack, but separating out the compute and storage in the cloud. So you keep all your source of truth data files on S3, great scalability, great redundancy, good cost vectors. And then you run your compute instances, your MapReduce jobs at that time, and eventually your Spark jobs, independent of that. And that allowed you to scale your compute and storage independently. And it ended up performing very well. Bested our expectations of what that could do. And that ended up being a very powerful architecture. But eventually we ran into challenges even with that. And so that gets into the Iceberg story.
Got it. And so this is all around like the so you guys started with Teradata. I mean, that was sort of the choice at the time. 2012, AWS launched Redshift. But really for you guys, it was, and you talked about the separation of storage and compute, which makes me think obviously like of Snowflake. That's sort of the hill that Snowflake claimed in the beginning. Can we talk a little bit about like what's the evolution? When I hear S3 and data lakes, I think about file formats like Avro, Parquet, and stuff like that. And that gives me my data in a columnar format in an object store. Where does Tabular come in, or Iceberg now?
Yeah, first let's talk about I think where Iceberg fits in that picture, and then we can talk about Tabular. And so, yeah, we're Netflix, right? We're writing all these Parquet files onto S3 in these directory structure. Basically, it looks like HDFS, but it's all on S3. And we're using Spark, and we're using, like most folks, a Hive meta store to basically keep track of like which tables do we have, what are the schema of those tables, right? And where do I find the files in S3? Like what are the partitions? What paths do I have to look at, right? And that worked relatively well, but it starts to break down in a few places. First and foremost is it doesn't support any sort of transactions like you would typically have for tables. Meaning, like you can add or remove files from S3, those directory structures. Hive has no idea that that happened, and it makes it difficult to be certain about the state of a table. And we ran into challenges like this where just data got corrupted or we had bad answers because we didn't have those guarantees of SQL tables. So that was one onus for Iceberg, is like we wanted to get table semantics back. Other things are similarly difficult in Hive, right? When it's just you have this very light metadata layer over, say, these Parquet files on S3, it makes it difficult to do simple things like, hey, I want to drop this column and add another column in between these two other ones. And just the relationship between Hive and Parquet doesn't allow for that sort of those semantics. And that was really limiting in a lot of cases. Basically, you have to drop an entire table or restate an entire table in order to, effectively change column names or change a column type. And at Netflix scale, this was like we had teams of data engineers running around just backfilling tables, and we're spending all this money on compute just having to do this. And we just felt that there had to be a better way forward. And like a lot of things, we found that better way forward and just looking back, right? What's the path forward? Well, what is it that we lost when we moved to this Hadoop ecosystem? We lost SQL semantics and tables
Right.
and the table guarantees. And so Iceberg, the genesis of that at Netflix was, how do we get all those SQL table semantics back, but retain the scalability and flexibility of this separated compute and storage that we love about that sort of Hadoop architecture. And to your point, like you said, it's very much the same problem that Snowflake, I think, saw and built a commercial product that does many of those things, and it's had a lot of success with it. Netflix wanted a lot of those same capabilities that Snowflake was providing. We just needed them at Netflix scale and cost.
Yeah, yeah, yeah. Well, I mean, I think it's almost fair to say that Netflix is Netflix is a hyperscaler, even though you're running or they're running their infrastructure in AWS. Yeah, interesting. Okay, so funny to see how the size of Netflix footprint is just like too big for any commercial product out there. Okay, so now, so we're talking about data in S3. And you migrated to Hadoop or HDFS to simply have to address the scale, but then you missed all the great things that SQL gave you, which got us back to a table format, which is Iceberg. That's sort of the story. And can we, like, when you talk to your first open source users today, what are the type of questions they have, and what is the first reaction they get or they have when they first are exposed to Iceberg and they start using it or they start getting their arms wrapped around it?
I think the first thing is just understanding what is a table format. Like we understand file formats, a Parquet or Orc or Avro. Like this is how we store bytes on disk. So what the heck is a table format? Like we only ever had file formats, and then we had databases, right? And the table format is this thing in the middle, which says we are going to provide a specification, a layer of abstraction that keeps track of all the files that actually belong in a table and what the schema of those files are, and where those files exist on disk. And that enables us to take the separation of compute and storage paradigm a step further. Because once you have a table format that's open, an open source project, an open specification, that means that any compute layer can communicate with the underlying data in a safe way, right? And you can have multiple different compute engines all operating on the same table safely. That's what Iceberg provides, and that's what we were after at Netflix. We wanted that exact behavior because we wanted to be able to stream data in from a Flink application and do transformation with Spark and do ad hoc BI with Trino all on the same table and have that be guaranteed to be safe. And that's really what a table format is all about, is giving you that capability.
So the source of truth really becomes the table, right? And now, because that's where I maintain sort of my golden copy, if that's the proper word, now I can throw all sorts of different compute engines at it, and depending on what the use case is, right? And that gives me a ton of flexibility. And well, what do you see? Like, where does what type of workload go today? Like, Trino, I don't know, Athena. I'm just like throwing out names, different query engines, cloud warehouses, Spark. Like, what happens? Like, once people have gotten that concept, it's like, oh, great, now I can do all of this stuff. Like, what type of workloads do you see, and what type of query engines and or databases do people use?
Yeah, I mean, that's a great question. And I mentioned some of them, and that's what we mostly see, right? For a lot of folks who are choosing an open format like Apache Iceberg, oftentimes it's because they want to stay in the open source world because they like the flexibility and the cost mechanics. And so, for stream processing, you've got your best in class stream processing frameworks like an Apache Flink or even Spark streaming. So that's what we see a lot when for sort of like I'm ingesting real-time data, but I want to get it into an analytic format. At some point, I have to put it into some sort of columnar store like Parquet. Well, historically, like to your point, we would write those files directly to S3, and those files in S3 were the source of truth. But we just up-leveled that and said, no, now we have this table concept. So we're going to write that data into a file and commit it. And we can get exactly one semantics from our stream processing layer, which that was impossible to do in the old world. Like you'd have a stream processing, writing files. Well, what happens when that fails? Are those files there? Are they not there? Should they be part of the table? Should they not be part of the table? Right. And so you needed this like, hey, we got to move our source of truth to a table that can be in control of what's really in and what's not. And just having a file on disk is not the truth anymore. And that's also like just a mental thing that people have to get past. We got so used of treating all the files in this S3 as a source of truth for a table. And now it's like, now we have this other concept that gives us more control. And so I said Spark and Flink for streaming applications, and CDC type applications. People who are doing CDC from their transactional systems. Then you've got, for transformation, I think Spark is still the heavy lifter there for doing ETL style workloads. But you've also got, and that can be any version of Spark, open source, or maybe your EMR or Databricks, any of these places where you can get Spark from. Athena just announced that they have Spark support. So anywhere you can run Spark jobs, that works pretty well. And then like at least for Netflix, we adopted Presto and then,
Yep.
Trino in the future, but we were pretty early adopters of that. And it was a huge unlock for Netflix at the time. We had done most of our analytic SQL workloads in either Spark SQL or Hive, and we just got massive performance gains out of moving to Trino and Presto at the time. So that's what we see a lot for analytics, SQL, even some BI style workloads. And then obviously at the end of the day, for the true BI workloads, your Tableau, Looker, are we doing BI work? Something like a Snowflake or a Redshift is fantastic for that. And now you're starting to see support for table formats like Iceberg available in those commercial compute engines. So, we're seeing customers who do Snowflake, they got Tableau talking to Snowflake, and Snowflake reading off their Iceberg tables. So that's great because now they can do transformation with Spark, they can do BI and Snowflake, and everybody gets the best of what they want for the cost vectors that they want to use.
Yeah, yeah. I mean, that's and I guess like data scientists, that crowd, they're probably more interested in going directly to the raw data source in S3 versus like, going through some SQL transformation layer in the warehouse. I would assume. I don't know, but you tell me.
No, that's absolutely it, right? And so this was really hard especially for data scientists. Like I have to know. I'm a data scientist. Already 1,000 things I have to know
Yeah.
in order to be effective at my job, right? Which have very little to do with actual data science. We're making their lives a little better, but yeah, it's like okay, I gotta figure out where on S3 these files live, and then I gotta figure out how to load Parquet files into my Python process, right? And what happens if some data engineer is in the middle of running an ETL job? I have no knowledge of that. I may am working off wrong data or old data. We had all kinds of these problems, right, at Netflix. And this is again where we're excited about Iceberg because even recently they announced a native Python client for Iceberg tables. So now as a data scientist, I'm in a Jupyter notebook or something. I can address a table. I don't have to think about S3 and Parquet files or any of those things. I can just say like, hey, I want data from that table. Here's my, here I want from these partitions or from these dates. and like the Iceberg, machinery handles making sure that that gets loaded into their pandas data frame or whatever it is
Yeah.
that they are comfortable in, right? So they don't have to do this mental translation anymore. These are huge unlocks for all kinds of different data personas.
Huge, huge. Yeah. And then I mean, we're talking about Netflix size, right? And what we've seen a lot that in the story of Silicon Valley, right? That like these projects start because you need to address a certain scale or cost factor that other companies like they don't have that bottleneck, right? But then the innovation moves downwards to much smaller enterprises and ultimately even like SMBs. Where do you feel today is sort of like the sweet spot of this? If I'm a like when is the right time to look into Iceberg or Tabular and where do you feel we are in terms of like adopters, like who's interested and who should look into Iceberg?
Yep, that's a great question. So I think the natural next step of adoption and what we're seeing with Iceberg and also for Tabular are all those folks who were also had already adopted this Hadoop on AWS type of architecture. They're like, I've got Hive tables, even though they're not real tables. I've got Spark running, maybe EMR or something, and I've got my data, my Parquet files on S3. So a lot of companies ended up in that architecture, and they're running into all the problems that I described earlier. And so those are it's the easiest for folks to pick up and move to Iceberg because Iceberg was born from that architecture. It's so obviously like it's the natural next step if that's where you are today. But to your point, part of the goal for Tabular as a commercial organization around making Iceberg easier and easier to use is to continue to move that capability down the stack. So, we've got customers now on Tabular, like they're just starting out. They didn't bring any of the baggage of Hadoop with them, but they don't know that they need a Snowflake yet, or they're not sure about it, or maybe it's expensive. And like we make it really simple, even if you're just getting started, to just like let's just start in the current best practices. You don't have to worry about anything legacy. So yeah, we're right now. I see adoption at that. Hey, I had the Hadoop on AWS, architecture. I needed the next thing. Iceberg the next choice, but we're definitely pushing that down to SMBs and startups at this point.
So yes, I mean, you're getting the best of all worlds, right? You're getting the problem of getting data into S3 has been solved, right? This is actually something I just talked about on another podcast. Like there's enough data pipelines out there, and even like direct integrations that dump it in there, dump data in there, and then with you now with Iceberg, I get the table format, right? Which allows me to use SQL to query my data, but also any other query engine where I can just like want to send my data into a different format or in a different engine. So, um, what do you think this will do to like, look, the modern data stack that's been around now and hyped and everything? And what do you think that will do to the modern data stack and everything companies have invested in the last 2 and 3 years? Like, and look, we're talking about tools like Fivetran, DBT, Monte Carlo, right? Like, what do you think is going to happen to that?
Yeah, I actually think it's quite nice because all that investment is still incredibly valuable, and you don't have to lose any of it. I think the nuance that we're going to see is that instead of having to um, dump all my data into the lake into S3, and then and then do transformations and then copy the clean data into my data warehouse, and that's where all this other stuff is enabled, right? The Monte Carlos and all the modern data stack stuff is enabled in like this in Snowflake or something similar, Redshift. Now you can still get all the value from those tools, which are built on SQL. That's what's great about why do they build them on top of Snowflake and Redshift? Because these are SQL semantics. We understand this. You can get all that because you can still leverage those engines, but you no longer have to copy the data from your S3 into another data warehouse, right? So like, just like, hey, we have all the raw data. Now we got to load this data into something else. Well, we just collapsed that piece. The raw data, the lake house for lack of a better word is really in my mind, like we now have a single source of truth. We're not having to make copies of our data. We have SQL semantics on our source of truth data on S3. And if we want to expose even the rawest data to our SQL engines, we can, but we can also just expose the pieces that we want. But it's not about copies anymore. We don't have to think about, oh, how do I do governance across multiple copies of data? Because this is the next big challenge for data. Is like, okay, what about the right to be forgotten, or how do I secure this data to make sure it's just like privilege of least access? And when you've got multiple copies running around, it becomes incredibly difficult. So we need to like one copy, lock it all down right there, without having to give up flexibility on the ways we can use it, like the engines that can leverage it. That's the big next step.
So the whole concept, if you go back in time to data warehousing, the whole concept was having data marts, right? Where you sort of like, hey, you have one central copy, but then you push some data out or copies of data out to different data marts. And in fact, that's something I see people having multiple clusters of data warehouses and everything, and having different business functions having their own little setup where they analyze data. Um, that all goes away, right? Like,
That all
and
goes away.
so no more copying data, no more data movement, and all the problems that come along with it, right? Like, am I looking at the most recent copy, right, of my data?
Yeah.
And does it, as you said, like, right to be forgotten, does it contain data that it shouldn't contain, right? So a lot of power moves into the data lake and to the table in the data lake, right? Like that's almost like the new center of gravity with Iceberg.
Yeah, I think that's right, and that's the future that we see and that we're excited about. Yeah, we don't have to make these copies anymore, and we still get you can still have the semantics of that, like being able to limit the lens that a particular group of users gets to come through and see without having to do copies and data marts, right? It becomes this concept of logical sharing or logical exposing the source of truth data without having to make a copy of it. This makes so many things easier, evolving it, securing it, deleting it when it's appropriate. Yeah, I think that's the big. Ultimately, that's the fundamental shift that happens. But it's nuanced. The nice thing is like all those layers built on top. The data quality tools, catalogs, all that stuff that we've seen in the modern data stack are still incredibly valuable in the new architecture. Maybe even more so, honestly.
Yeah, yeah. And so now you're the head of product, and you're like right now, I guess it's all about building traction and getting, proving out the use cases. Because like when you guys started, when did you start? A year ago, a year and a half ago,
Yeah, just about a year and a half ago, summer of 21.
as a company. The project obviously has been around a little bit longer. Um, so comparing like the short term, meaning like the 1 year horizon, to the big vision 10 years out, like what's in your head? And I know like we're like huge hypothesis, but like what's the big vision? Like what are you building? What's in your head?
Yeah, what's in my head is this feature or state that I talked about, right? Where you've got single source of truth data, you have your choice of different compute engines you want to use against it, and the ability to create lenses for different people, both internally and externally, of how they're going to interact with that data. Once you have that, a bunch of things start to unlock, which are interesting, and we're already starting to see like data marketplaces emerge, right? I think that becomes even more the case. Like for a long time now, doing data interchange with between two companies was like, okay, well, you have an FTP site somewhere, a server I can ship my CSV files to, or like we evolve that to like, oh, give me your S3 bucket path and let me upload my maybe Parquet at best files over there. But still, like I then have to try and ingest that into my world and do translations about it. And what happens when you change it? Do you want to revoke access? You can't because you've like shipped copies. All that goes away, right? And now like you were all not only internally operating on the source of truth, but we're able to create lenses on that data for all of our customers. Like we're doing this already at Tabular, which is fantastic. We ETL a bunch of data about access and audit logs, inventory lists. We take all that, we create these canonical data sets, iceberg tables, and then we create lenses on them for all of the customers so they see the chunk of that data that's relevant for them, right? And we can lock it all down with security and et cetera. We can evolve it without having to for them to do anything. We can change the scheme of it, and there's no work on their side. And every single computing tool that works with Iceberg immediately works with this data that we're sharing with them. Like, right? That's just fantastic. So I think it will
Yes.
really start to reduce the burden of data engineering that's not value add, right? There's still a lot of value in data engineering, but there's a bunch that's not. And I
Yeah.
think,
Yeah.
my goal is to sort of hopefully get rid of most of that, so that data engineers can get back to doing really value add stuff for their organizations. And there's whole new lines of business that open up on top of that. We've talked a little bit about applications in the warehouse. What does that look like? But in my mind, that's, well, if you have, let's say you have a fantastic entity resolution algorithm, awesome. I have all this data. I can give you a lens to that data. You can do that algorithm and write it back into my world in an iceberg table. And now I can do my ML models on top of it directly, right? So you can basically sell data enrichment as a service, or data transformation as a service, or models as a service, without having to, worry about, oh, am I shipping data, copies, am I getting it back? Is it current? All those problems go away. So a bunch of new capabilities get unlocked, which I'm excited about. And that's, sort of the 10-year vision.
Yeah, yeah, and I'm thinking about like who's to lose here, right? If you're successful, assuming it's a zero sum game, which it often is not, but it almost like in one sense, I feel like existing cloud warehouses have something to lose, right? Because you're moving the source of truth into your data lake, into something into an open format, and then you can bring any compute engine to it. But it almost feels like because you're unlocking so many new capabilities that overall the workloads are going to go up. I still want to use my cloud warehouse because they're good for certain workloads, and I'm still going to use Trino because they're like that's good for certain workloads. It almost feels like you're just unlocking more data and more use cases, which is going to lead to more analysis and more value. So I think you're going to be like, to me, that sounds like you're going to be super successful, but others don't really have to fear anything because overall, it's just like you're unlocking more data. Is that a correct assumption, or how do you guys think about that?
I hope so. I mean, we're still having, but yes, that's our goal. That's how we think about this problem as well. That we're just really going to expand the amount of data that's available to more people. But
Yeah,
that's more analysis, more insights, more analytics that can get done faster and easier. We don't necessarily think that means, ours is really just this. Yeah, it's table formats, it's storage, but we think that that's makes more available to more compute engines. Potentially,
totally.
there's a it becomes more, the compute engine space becomes more competitive because you can't rely on the fact that your customer's data is locked into your warehouse anymore. Like, your compute layer really has to be better than the next compute layer over. But that's I think still a win for the community, a win for data and ecosystem, that
Totally.
these tools can specialize at being really great at something and unlock a lot of value for customers there, and not have to worry about, well, how do I also do storage, and okay.
Yeah, yeah. I mean, if we look, I'm just going to take Snowflake as an example, right? They made a lot. I mean, they made a lot of things easier for a lot of people. They're sort of the workloads they attack were either Teradata, but also Redshift, right? Um, and all of that became easier. If you look at what they're doing now, how they position themselves in the capital markets, they're going after verticals, right? So they're going after solutions for finance, for retail, for e-commerce, and I feel like almost like that's their value add, where they provide custom solutions to it, because in the end, as we said, like if the cost of compute goes down, everyone benefits, right? I think like it's just the natural cycle. um how do you So let's talk about the human side. What is the skill set that I need to hire now as a company if I want to work with Iceberg? Like, what are the processes and the skill sets I need to put in place to be successful?
Yeah, so, and that's really where I think Tabular comes in, is trying to lower that bar. But if you're going to use the open source Apache Iceberg project, today you need folks who are well versed in the most of the big data tools and technologies, right? You have to understand object stores. You need to understand how these distributed data processing engines work, like Spark and Trino. Um, and all the interactions there. And then you also will need to understand how Iceberg works, because ultimately, to be successful, Iceberg tables do require maintenance, like care and feeding. Um, so it's similar to, if you were going to run Postgres or MySQL databases directly on your own, like you need to understand how those technologies work, databases work, so that you can set the right indexes and the right configuration settings, all those knobs and levers to turn and tune. And it would be similar, running Apache Iceberg internally. And this is, again, what we saw across all the early adopters, Netflix and LinkedIn and Apple. They all have teams of these experts who know all this stuff. And then obviously Tabular's goal, like maybe where you're going, is to try and remove those barriers, like to be successful with Tabular, since we're providing all that stuff as part of our product, all the Iceberg best practices baked in. We do all the maintenance activities on your behalf, so you don't think about them. As far as you're concerned, Ryan is my other co-founder, calls it's the bottom half of the data warehouse. They just SQL, and you have tables which scale basically infinitely and can work with any compute engine at your disposal, and you just need SQL to interact with them. Tabular handles the rest, and that's what we're trying to get to.
And so, for me, what's the, as a user, what's the best way of starting with Iceberg and Tabular? Like, what's the journey? What do you see, and what do you recommend people to do as the next best step?
Yeah, a lot of it depends on where you're coming from, right? If you're just starting out, then great. Like, just spin up Tabular. Now you've got a bottom half of a data warehouse, and try some different computes. Like, try Snowflake and try Athena and things where you don't have to run any infrastructure. Super easy, super lightweight, nothing for you to set up, right? That's the easiest way to get started. You can run a very sophisticated data warehouse without having to run any of your own infra. That's nice. However, if you're coming from like, oh, I have all this Hive Hadoop stuff already set up, then the world looks a little bit different, right? Then you're like, okay, let me spin up Tabular and let me take some of my Hive tables, and we have some capabilities to, like, let's basically import those, transition those into Iceberg, run some of our workloads on top of that, see how that all works. We've seen incredible performance gains from just even making that transition, and and you start there, and you can for when you have a bunch of legacy stuff, the process is more like any migration. Like, take your most critical workloads, or the ones that benefit the most from the new capabilities, move those first, build expertise, build comfort, right, and then migrate everything else over. So depends on where you're coming from, but both are very viable.
Yeah. Pick one workload, right, and start experimenting. That's usually the path to success. Anything I forgot to ask that I should ask? Because this is such a new world. I have to admit, like, in prepping here, it was eye opening, and I thought, like, gosh, there's a lot to uncover here. Uh, Some of the things like, what should I cover that I haven't covered, Jason? Like, what are some questions I should ask? Turning it around to you. Sorry, I don't mean to
Yeah,
turn.
no. Like I think once you have delved into this space a little bit, and table formats, and you're starting to understand what the future architecture might look like, and you're getting excited about that prospect. And I think the national question is, okay, what alternatives are there? What alternatives look like, or what are the trade-offs? What am I giving up by moving to this, right? And in terms of alternatives, there are other, like, table formats in particular. One that comes to mind quickly is Delta Lake from Databricks, and it exists for a lot of the same reasons that Iceberg exists. Obviously, designed from a commercial perspective instead of in industry, the way that Iceberg grew up. But there's a lot of similar capabilities there. When folks ask me about how do I think about Iceberg and Delta, I think they are both super important for getting us to this future state. And much like file formats like Parquet and Orc, and columnar formats, open columnar formats, got us a long ways for analytic benefits and performance. These table formats will do the same. And you're I think they're both open, and you're not locked into anything, and so you have some agility there going forward. And the other big is, like, what am I trading off by moving to these table formats? That I think I don't think you're really trading off anything outside of, there is a learning curve for just getting your mind out of thinking about files, right? Like, you should not ever have to worry about files ever again. You just have tables. Like, go back to just databases. So getting people, though, like, we've seen, once people get used to working a certain way and they're used to directly reading Parquet files from S3, you tell them, like, they have this table instead and has all these capabilities, they feel like they're losing something, right? So just getting people through that, like, oh, but I can't directly load these files anymore. Like, no, you can't. You have to go through the table, otherwise you might be getting wrong data. And it's just they feel like they're getting some capabilities taken away. It's more mental,
Okay.
but
It's
yeah.
mental. Yeah, that's usually, yeah, I understand that problem. Well, maybe actually, so one last topic maybe we want to cover is the relationship with the cloud providers. And let me know if you cannot talk about that, but it's an open source project, right? You're commercializing it, and it's obviously very disruptive. So, how do you feel like what's your relationship going forward with the cloud providers, GCP, AWS, Azure? Um, because it's some like, and you mentioned Delta Lake, and I'm thinking of their relationship, Databricks' relationship with those cloud providers, where the cloud providers became more of a distribution channel than a competitor. Where do you feel is the future of Iceberg and Tabular with the cloud providers?
I think it still remains to be seen. This is a very good question. There's going to be a lot of nuance probably here. I think it mostly is the same. It becomes, a massive distribution engine. I mean, Iceberg is designed to work, from the ground up in the cloud. That was built at Netflix. It was all cloud. In fact, one of the big things that it does great is take advantage of object stores versus, file systems, like HDFS. And that holds true across all these cloud providers and their object store scenarios. And you're seeing great adoption and sort of support for the format in the cloud providers, right? So Amazon's got support in EMR, support in Athena for Iceberg, and their engines work well with Iceberg tables. That's great for Iceberg, and it's great for Tabular. It gives customers more choices. Same thing for GCP. Like they've got BigQuery now, could directly query against Iceberg tables. That's fantastic for everybody. It just continues to unlock this future world that I'm talking about, and I think we'll see similar moves from Azure as well, just because this is what the market ultimately needs and wants.
What they want,
Uh,
yeah, yeah.
yeah,
Jason, how can people reach out to you if they want to learn more about Iceberg and Tabular?
yeah. I mean, check us out, tabular.io. You can reach out to me. It's jreed@tabular.io. If you can send me emails directly, that's fine. Connect with me on LinkedIn. Or there's the Iceberg open source community Slack environment. Really vibrant community there. People talking about Apache Iceberg, and I'm hanging out in there as well. So
Oh, that's always
find
the
us in those
best place.
places.
That's always the best
Yeah,
place. I'm trying to, well, let's do a quick screen share here of your website to see where we can find all of this stuff here. It's always fun to see. So here we go. Is there a link? Obviously, there's the three of you here, which is cool.
yeah.
Is there a
There's a bunch of
link?
stuff in that YouTube channel that's got a bunch of Iceberg, 101s, and so you can
Oh,
find
I
us
like that.
there, talking about Iceberg.
We're gonna go to this tab here. There's a lot of stuff here. Hold on, here we go. The channel. Okay. And then your community, I would assume, link here is. Can I get a Slack link to?
Yeah, I think that the fastest way to find that is probably the Apache Iceberg website, like the
Okay.
apache.iceberg.org, and then um, there is the
Here we go.
yeah,
Slack.
right there, the top right project,
Mm-hmm.
and then join, and then you've got links here to join or even right from the front page. I even saw that there's links to join the Slack meeting and
This
such.
is
Yeah,
Slack
right,
community.
right at the front
Awesome.
page. Yep.
Awesome. Good stuff. This was super insightful, Jason. Thank you so much. Um, I think we should do this again in 6 months to see where the progress has been of the community and
Happy
everything. This
to.
is
I'm
exciting.
happy to. Yeah, thanks for having me on, Lars. I appreciate great questions, and hopefully somebody walked away with more knowledge than they came.
Oh, for me, it was super useful, and in fact, like you could probably sense a little bit by my way of questioning. It's a little new for me as well. I come more from the analytics world and cloud warehouses, so going one layer down now was really insightful. So it was super helpful. Thank you so much, Jason.
Awesome.
So that was Jason Reed, co-founder and head of product at Tabular, the company that commercializes Apache Iceberg. Jason, thank you so much.
Thank you, Lars.